So it's about time to start. It's my real pleasure to welcome you here. My name is Maria Gabriela Serra. I work in the strategy department of ESA, and I had the pleasure as well to put in place the first strategic risk management framework ESA is using. So I was the so-called agency risk coordinator of ESA for 8 years. Now I'm working on other topics, but still risk management is at my heart. And I wrote a paper as well this year for this conference on generative AI, the topic here, together with risk management to see if it could help us really identify risk, assess risk, mitigate risk. So I had really a great and vested interest in this panel. And it's my pleasure first to invite all our distinguished guests and speakers. So I'll start in alphabetical order. Professor Adam Ebdin from the Centrale Supélec Engineering School. Thank you, Professor, for joining us. You, round of applause. You are working in a research team in risk management, and you will tell us as well how you use generative AI in your team. Then I would like to welcome Mr. Massimo Comparini. Massimo, I don't know if we need to introduce you, everyone knows you, but so Managing Director at Leonardo. Congratulations for the new position, by the way, because you changed a month ago. So then, in alphabetical order, if I'm not wrong, it should be Mr. Christopher Geiger, the Head of Audit and Enterprise Risk Management at Lockheed. So representing the other side, the industry on the other side of the Atlantic. Then we have, if I'm not mistaken, Mrs. Mariella Graziano in alphabetical order, 3 Gs, so I have to be careful to invite the right person. So Mariella, you are my hero, you know that. Mariella was in hospital 2 days ago, so she came specifically for this panel. Thank you so much. A big round of applause. And last but not least, Adam, who is the NASA's Council for Ethics. Thank you, Adam, for joining us, and you will give us also some very great insights on artificial intelligence and how we're going. Thank you. Thank you, everyone. So, 1, 2, yeah, it works well, perfect. So with no much ado, there's a timer here, so already 3 minutes for the introduction. So, but I'm sure you have many questions, so I would like you really to also be able to ask your questions in the public. I would like to address our young professor here. Adam, we know each other for quite long now, and you have been working on generative AI and on AI. And what is interesting is really to set the scene here first, to maybe have a definition, you as an academic, what do you understand by Gen AI in comparison to AI, generative AI, what's the difference? And maybe as well tell us, I heard, I heard personally, and I'm sure many people in the audience heard, that we say that generative AI is a stochastic parrot, that it's not intelligent. Maybe you can tell us a bit about that. What are your thoughts about that? Is it really a parrot, or is it really intelligent? You probably have your views. And maybe last but not least, I know that you have your research team is also working on using Gen AI. Can you give us maybe some examples? Thank you. Many questions, but it will be passionating.
Thank you very much. Yeah, it's working. So thank you very much. First of all, yeah, indeed, we started to work on generative AI, using generative AI models a bit in our group. So I'm going to be speaking as a member of the research team. So also like displaying a bit what our research group at Centrale Supélec in the Université Paris-Saclay are doing. So we are in the risk reliability and resilience team. We work on developing risk reliability and resilience frameworks and methods for complex systems engineering. And so the question that you asked me about the definition of AI, I think is a hard question because obviously, like there's no easy way to define a set of tools, and probably each like people coming from different disciplines, they see it in different ways. However, I'm going to attempt maybe a try to give my understanding of AI and how we use it. So the artificial intelligence is the set of technologies that have been developed in the past decades that more and more mimicked what we usually associate to human intelligence capacities. So this is like the more generic definition about that. AI, like the development of these technologies throughout the years have been obviously exponential in the capacities of what these algorithms and these technologies can do. However, the recent advancement in GenAI specifically, and this is what the separation between AI and, or like the set of definitions for defining what a generative AI model is, it's a subset of the AI technologies that is associated to creating new content. So generating new content that was not existing before. And this generative AI definition, or like the use of the term generative AI, was coined by Stanford, a team in Stanford, just to illustrate or to highlight this capacity to generate new content. I think everyone is familiar, of course, with the content generation of text, like ChatGPT and LLM models, but it is also used in other contexts to generate images, videos, translation, and so on. So these are the main differences. It's a subset of the AI technologies that have this ability to generate new content. And then, so on your question for stochastic parrot, I mean, I thought about this a lot. I mean, yes, because if you, like at the end of the day, all of these technologies are pretty much based on stochastic, you know, like some form of probabilistic models that try to, from a very large amount of data, try to predict the next set of data, or to regress these data to some information. So in this sense, yes. But in the general philosophical sense of, okay, what is intelligence? And is intelligence just the ability to use this information to create new content or to create new information? And in this sense, I do believe it's intelligence. So it's not just a stochastic parrot in the sense that it's repeating something that is useless based on information that is fed, because obviously these tools create content that is very useful to be used in industry, in academia, and everyday life even today.
Thank you very much. Maybe tell us a bit what your research team is doing on GenAI.
Right. So I'm going to briefly to also leave the floor, but briefly say like our
in relationship with risk, of course, exactly. And how you identify risk.
Our research team in reliability. So we do have a professor and a few PhD students who are trying to look at the LLM models, so the foundation models that exist today. Are they good enough to be used in the context of reliability engineering? Right. So, for example, we expect that people will be using like LLM models for all sorts of applications. Can you say maybe? Yeah, so large language models, indeed. So large language models is the most known form of generative AI models that everyone is currently probably using in any case, like ChatGPT, right? So this is one of the very well-known large generative models. And LLMs is being used today in everyday tasks, right? Like you want to write, I don't know, your resume, you want to do something, like everyday tasks is being used. And we suspect that people will use them as well in their jobs, right? So for example, someone wants to write a risk report or want to do a reliability analysis on something, will probably also go to these tools and use them to support the functions that they're doing, which is fair enough, and that's very good. So the team in our university, what it's trying to do is trying to see, using these models, what do you get really something that is trustworthy and reliable for reliability engineering? So we do have a lot of expertise in reliability engineering, and we have a lot of expertise in risk analysis. So we know, like we have expert systems. The people who maybe in the room work in these domains know that we have, like usually you use expert system based on expert knowledge about the specific component or the specific task that you're trying to do. And we compare the output of these LLM models to these expert systems. And I'm just going to leave it here, a cliffhanger. The reality is that today, these systems are not actually good enough for reliability and risk assessment. That doesn't mean it cannot be good someday, but at the moment, they're not really suitable for these tasks.
Maybe that's a message of hope that we're still going to have some job in the future if it's not reliable enough still. But you said something about trustworthy results. And I'm going to address you now, Christopher. about you at Lockheed Martin, because you told me that you're using generative AI in your enterprise risk management team. You're heading as well the enterprise risk management team. And I would like you maybe to tell me how you use AR and generative AI, both of them, why not, to generate risk scenarios, okay, to a bit foresight and so on for your project. And maybe you could give us some really tangible examples on sustainability, because it's the theme of this symposium here this year, sustainable space. So maybe you could give us some examples on that.
Yes, of course. So first, I'll get to the sustainability part. I know that's right in the meat of the title here for today's presentation. So Lockheed Martin has actually been using AI before generative AI for sustainability, and then when the LLMs kind of jumped onto the market, them as well. So I'll give you two examples. We have a partnership with NVIDIA to do a digital twin of the Earth weather. So for NOAA, the U.S. National Weather basically organization, and basically this digital twin uses AI and enormous amounts of data. So sea level or sea level information, but also sea temperature. So a lot of space-based temperature data and lots of other data that goes into it to actually help inform weather prediction. And this actually came out of our risk management work, because we have 150 sites around the planet, right? We're doing materiality assessments for sustainability, and we also look inward to see what data can we use ourselves to actually mitigate our own risks to do with whether it's climate change or other issues. Another example that came out of that is when we did look at all those facilities, we said, of course there's climate change, sea level rise risk, but as the climate changes, there's also different fire risks, right, or water scarcity. And fire in particular is something that came up on our register as interesting. We had to look back at ourselves and say, well, we have firefighting helicopters, we have firefighting aircraft, we do artificial intelligence for tactical scenarios. Why couldn't we do AI tactical scenarios for fire? Why couldn't we help people deal with remote wildfires and predict them using all the data that we have? So we're actually now in the business of firefighting intelligence as a service. Because a lot of organizations, firefighting organizations, are not, flush with money, but they do need the information to pre-position assets and actually try to predict where a fire is going to go to save lives, save property. So this is actually something that came out of our sustainability group to help our own risk management that actually became a product. So those are kind of two examples related to sustainability. I'll also mention in our enterprise risk management group, we use the LLMs, the generative AI, to read all of the comments across the company. So if you imagine you have a small risk management group and nobody can read all of the risk statements and the programs. You have thousands of programs in our company or all of the assessments for new business. The individual executives, right? They all go read all of those, but no one can read all of them. Well, of course, generative AI can. And so we're actually able to tease out emerging risks in the company by reading unstructured data, right? AI was always good, like those weather examples, with structured data. You have numbers. But this generative AI can create intelligence, or at least for a human to convert to intelligence, from all this unstructured data, to read it, to do sentiment analysis, and then to bubble things up. Now, to Adam's point, we don't just take that raw data and run to the board of directors either. So we have some smart humans look at that and tease out things. But I can tell you that it has, in some cases, brought things to light before management was aware of them.
So you did find the results trustworthy. So that there was can you give a rough percentage of how much would you find? I mean.
And the thing is, if you just ask a raw LLM that's been trained from the entire internet, right, then you're often going to get hallucinations. You're not going to know where the answer came from. There's no reference to it. So we instead have our own internal LLM developed just in our company, and we have a RAG, an RAG, that actually just has our data in it. You attach to it. I think of it as a short-term memory for AI. And the AI, if you use its foundational model, it can't tell you where it got the information from as it generates predictive text. But if you put it in the RAG, and it's essentially short-term memory, it can reference it. And so as it talks to my auditors or risk managers, it tells them not only, yes, this is a risk in this type of the business, but it actually has a reference, a footnote, they can click on it, and it goes exactly to that document of the millions of documents that it's input, and says, this is where I got this information. So we actually don't find it hallucinates on that data.
It is identifying risks, and there is a human, a risk manager behind, who just checks upon what he has identified. So that's very interesting, because in the study we did with a colleague from Aerospace Corporation and NASA, indeed, I was mentioning at the beginning, and we wrote an article on that, the weakest part of GenAI was in the risk identification. But this having been said, you talked about your own chatbot, and we had only public information. It was on the Artemis program, and identifying risk on Artemis program. And of course, I mean, we could not use confidential information. We took only publicly published information. And this is very interesting, because when you are using your own LLM, then this makes really the difference. And you, Mariella, I come to you now. You told me you were using your own chatbot, indeed, at GMV. And maybe you could tell us as well a bit, you know, because you use it at different level. You use it in management, but also on products design. So it's quite risky, risky to use it on products design. But maybe you can give us also some examples and how you're using your own chatbot, as a matter of fact, to identify risk or assess risks or even mitigate risk.
So thank you very much for the invitation to look at Martin, and for also the patience with me. Yes, indeed we are using, I mean, GenAI is a company that just made 14 years. So
your microphone close.
Oh, sorry. We can rely on lots of data, lots of experience, which is one of the topic of the GenAI, having reliable data and then secure them. So we are using AI in general. In project, we are using AI in product, and we are using now we have some pilots within some pilot project within the company to see how we can take advantage and make our, let's say, daily life better. Because for me, I mean, I'm a hooligan of natural intelligence, so I see artificial intelligence something to make better life, not really to put aside the natural intelligence. So. One of the problem that, as I was mentioning, we have also a company that works in AI, also associating with cybersecurity, because as I was mentioning before, in whatever the tech, okay, depends on the technique you are using, but you have always the problem of data. You have always the problem of having reliable data, or the data that really are useful for what you want to do, and then there is a problem of security. Because especially if you have your own chatbot, I mean, you want to, which we do, we want to protect our data. So we are injecting all our experience there, and trying to come out with interesting elements. So what we are using, depending on, you know, that GenAI is working in many different areas, maybe too many sometimes. So in the area of let's say more technical aspect like GNC, robotics, space traffic management, we are using there, and we are not using generative AI. We are using other technique, deep learning, CNN, LSTM, so other techniques that let's say, because we need to for instance, recognize object within our images for our navigation systems. So it's a different story there. But we do have a problem there for the data, because there are not so many data in a real space system, which is one of the problems. So ESA and many of our clients are opening lots of ITT saying AI for GNC, AI for operation, AI for, this is always a problem, because AI is a word. I mean, first is, what do you mean with AI? Then going to the generative AI, I was mentioning that we have different pilot within the company at the moment, taking advantage, working with our own chatbot. So, and we have identified specific problem that a company normally has. One is, for instance, the knowledge management. This is something very important. So we have a project that now is called like GMV Knowledge Finder. And the goal of this is really to identify within the, I mean, you know, we are still a family company, but we started as a new space company from a university of 2 people, and now after 40 years we are at 3,500, so different story. And knowing within the company to whom you might talk, or where the right information are, or what is giving a solution to your problem is something very important. So we have a pilot there where we are putting all the information, centralized information for the company's employee. So they can make very easy question, who's handling this technology, to whom shall I talk for this specific problem?
That's fantastic, no? Because I mean, we've all dreamt of having that in any company, you know, a knowledge management tool telling us who is the expert in this area. And specifically, I mean, at ESA, we worked a lot in blocks of projects like Rosetta, Mars Express, Venus Express, blocks of projects. So of course, having lessons learned. So I suppose you use it on your lessons learned as well.
Yes, and but because what we did is to do, I mean, as engineers, to make, okay, which one are our problems? My problem is knowledge management, my problem is organization, my problem, for instance, is making a good proposal. So we have another project, it's called AI-driven proposal generation, GenAI proposals, frankly, basically. So what we do there also is injecting lots of information on proposals, and then this, I mean, because there are some proposals that need a little bit more work, but there are a little bit more standard. So we are having a pilot for generating a proposal, good proposal in a more efficient way. Of course, then you have to work on them.
Gaining a lot of time then,
yes.
huh? Thanks to GenAI, as a matter of fact. It's a bit what Chris was saying. So you gain so much time if you can inject all these reports, and then it makes a synthesis of all of that. Well, you gain a lot of time. Indeed. Thank you, Mariella. Now, I think first I want to thank Massimo, because you were at Thales Alenia Spazio, and it was the only company who really replied very thoroughly to the survey we sent them for the paper I was writing. So Maria Antonietta was very proactive on that. And again, as I said, we identified we asked ChatGPT-4, please identify the top 20 risks on the Artemis program, okay? And then we realized that, okay, the result was not so good. So we trained the tool by injecting documents we found on the net, NASA reports, etc., etc. And then we re-asked the same question, please give us the top 20 risks. It was a bit better, of course, but it will never be as good as if we were able to access the chatbot of NASA with also, of course, confidential document. But you were using ChatGPT-4, so of course we had no way of accessing that. But this having been said, on mitigation plans, ChatGPT-4 scored quite high, above average. So people like Maria Antonietta, other people said, wow, that ChatGPT-4 is giving us good mitigation actions to solve risks on Artemis program. So we were quite surprised. What do you think, Massimo? I mean, how are you using yourself within Leonardo, but also you can talk about your experience at Thales Alenia Spazio. How are you using generative AI and AI in general? I mean, we can talk about both, of course, to help you identify and maybe mitigate your risks. So giving you some ideas of solving your issues on programs.
Thank you, Maria Gabriela. I think it's an extremely interesting topic also because we have different angles to see what we are discussing. Of course, one angle is what Chris described in terms of processes, in terms of knowledge, and by the way, also Maria, in terms of organization knowledge and all of that, which is extremely important due to the complexity of the mission that we need to address, like Artemis, and also we have many examples at the European Space Agency level. Let me take the angle of how to mitigate risk for so complex space mission from engineering standpoint. What I mean is that, okay, you refer to Artemis. We know the complexity of all the missions and all the vision on the Artemis program. Okay, we go around the stands, around the booth, and we see pieces of hardware, pressurized model, rover, automatic machines. Myself, I always made this example. I don't know how many astronauts we will have on the surface of the planet 10 years from now. Let's say 10 or 15, a number. I'm sure that for each of those astronauts, we will have maybe 10 or 15 machines helping him and her to make their job. And of course, I cannot imagine that women and men on the moon, they will have 10 or 15 different joysticks and control those machines, like our TVs. You know, we have so many telecom. Why I say that? Because of course, we will have those machines that are progressively more, let me say, more intelligent, AI power. I don't know, GenAI power. This is another topic that maybe we can touch in the second round, because, you know, Adam gave a kind of, let's say, definition about AI, GenAI. But then, of course, when we will really injecting GenAI inside our systems, we need to understand what is the target and how we, I know it's difficult to say, but how we can control that in any case, if a Gen AI powered machine is on the moon, what is the control that is doing the right things to protect the life of the people that we are there. So I said that because imagine how we are using AI, and then let's talk about GenAI. First of all, we need to understand what is the target of all those machines cooperating with the man, which is extremely important also to study in terms of philosophy, how the man will address the challenge, first. And second, imagine the amount of data that these man-machine cooperation system will generate, and how, at that point, GenAI may help to manage the risk ex ante, as you described, but ex post. I mean, after that a mission is in operation. And I'm convinced that very soon we will be in a situation where the astronauts could not have the time to call back to the Earth and to say, Houston, we have a problem. Or I'm used to say, Turin, we have a problem. And they need to take a critical decision there, relying on AI and GenAI. So this is just to say that to the question, how are you using AI and GenAI, it's a bit more complex looking to the missions that we are targeting first. Second, and I highlight on the sustainability, Chris gave an angle. Of course, at European level, we have Destiny, Destiny Earth, so I mean the digital twin of the Earth, and again, and we are using AI to have those prediction models from huge amount of data that generate with our sensors. Just an example, Copernicus program is one very rich database for all of that. But let me stay still for a moment on the moon, just imagine that. So how to make sustainable those missions? You mentioned about Artemis program. It's not just to go there, it's how to make sustainable over the life cycle of the missions that we have. And I really believe that AI is and will be a fundamental tool. Maybe in a second round, let's talk a little bit more on GenAI. Also with respect to a view that we have as a group, you mentioned as Leonardo as a group, where the convergence between the digital technologies, high power computing, not necessarily on Earth, but also in space and on the surface of the planet. Artificial intelligence, cloud in space, all of that are infrastructure that will be AI power. So we are working a lot on this, and the work is on the specific technologies, but also having in mind all the life cycle and the sustainability of those amazing missions. It's not just to launch a single satellite.
Talking about sustainability, I suppose you are also working on collision avoidance and space traffic management processes using, of course, AI, because the goal would be indeed to be able to use AI, and probably already starting doing it to minimize the use of human being to deorbit or whatever if there's a collision happening.
Okay, we know, I mean, the motto of this year of the IAC is responsible space for sustainability. So we know what is going on in the low Earth orbit is going to be more congested and more populated. And of course, if we follow the exponential growth of debris and objects, no way. I mean, it's AI. It's a fundamental tool that today already is part of the space domain awareness of command and control to give right information, to give alert on possible collisions. And okay, we know SDA, space traffic management, and space surveillance. It's fundamental to have a sustainable space. And I think, okay, Mariela mentioned what they are doing. I mean, everyone in Telespazio, that of course we have ground operations and ground systems. We have a huge amount of AI that already today help to take decision and to give alerts. So.
Thank you so much. So I'm going to go now to you, Adam Greenstone. So you as the NASA's Agency Council for Ethics, because we talk a lot about generative AI, but how about, the way we use it? And you're interested in that personally. I mean, that's in your role. Can you give us your thoughts on what you just heard now from the panel, and maybe tell us as well if we should in the future regulate more, because now everyone is doing what they want in AI. Should there be some regulation? You know that in Europe we had one, the AI Act in July coming out. What are your thoughts
Thank you, Maria Gabriela. An honor to be here. I am not an AI expert. We have at NASA a chief AI officer. We have lawyers that work with AI far more frequently than I do. So why is Greenstone here? I have a perspective, and that is, as the Agency Council for Ethics, I have a perspective on the relationship between ethics and sustainable space exploration. The big picture, that's a key part of this conference. How do we get to sustainable space exploration? And it's my contention that ethics is part of it. Now, I'm going to tell you what my takeaway is, and then I'll get a little into what we're doing at NASA. A pitch that I have today is the importance of self-regulation in doing AI. As Maria Gabriela mentioned, yes, there's a new European law, the AI Act. The Office of Science and Technology Policy and the U.S. Executive Office of the President is a blueprint on AI principles. At NASA, we have an AI framework. Of course, government regulation is coming, but my point is not to wait for it. And I think that's one of my takeaways in the presentations here. They're not waiting. They're not waiting for regulation to do AI the right way. I'm going to come back to this sustainable space exploration theme. Let me tell you a little bit about what's going on at NASA with AI. Now, first of all, what I would encourage you to do to learn, just do a web search, AI and NASA. We have a robust web page on some key AI activities. Here are some examples. Optical navigation. Systems that when an astronaut or a robotic spacecraft is on another celestial body, take a single picture of the horizon, a system that will be able to use the mapping data to be able to determine where that astronaut or spacecraft is with the same precision as the GPS system as if they had one, but they won't on that celestial body. A next step is virtual worlds, a system that will generate data representing a virtual world that can be used in planetary landing. As the spacecraft comes down, what are the dynamics of what it's going to face using the limited information that is available about that celestial body to determine what are the characteristics of that virtual world. The Mars, let me get this right, the Mars Organic Molecule Analyzer, MOMA, that's going to be on the 2028 ESA-led mission to Mars. Machine learning that will enable guidance to the mission team on, all right, you've drilled for a sample, what should we apply to that sample? What experiments in a world of limited capacity to get the most scientific value? And then when to drill next, recommendations to the mission managers. That's a step towards autonomous robotic spacecraft that will generate their own data and then apply that data to make their own decisions on a solar system mission autonomously. That's an example of what we're doing. Now, how does ethics and sustainable space exploration plug into this? So let's step back. A very important aspect of space is its signaling value. And this isn't just speculation. I mean, there's scholarship in this showing through history and economic analysis that for a few centuries now, countries and companies and individuals and other organizations have made investments in space and use them to signaling about national values, individual aspirations and priorities, corporate strategies. There's a corollary of this, that because space gets great airtime in humanity's attention, and a reputationally adverse event in space will be heard with a far greater amplitude than a similar event in other industries and sectors. This is where we step back and say, as I think our deputy administrator mentioned earlier in the conference, the importance of applying the communal knowledge of humanity. We work together to build the space exploration enterprises of the future. Governments, industrial partners, scientific organizations, academia, and others. A reputationally adverse mistake by any of those entities can set the entire communal enterprise of space exploration back. Now, here's where I get to regulation. It's going to take, in my view, many years for governments to get their arms around what is effective and useful regulation of AI. We see the same thing going on in crypto. What that means for the moment is that it's vital for space actors to make these wise decisions themselves. What is the responsible way to deploy and use AI? You know, we've seen in the history of space exploration many examples where private actors have made their own decisions, not mandated by government requirements, to do the right thing, to avoid adverse events that set the communal effort towards space exploration back. And I think that's my key message and takeaway, that during this period, while we're waiting, the importance of self-regulation to help our communal effort.
Thank you, dear Ed. I'm just having some thoughts on the fact that, okay, you say we should auto-regulate, so every person should be, like, let's say, responsible. I might have some doubts on some of your, let's say, private actors, and one of the biggest private actor on regulation. It might be a bit tricky to leave it to people to decide on their own. I don't know if for example, Elon Musk, I'm thinking of now, knowing how he likes regulation, would be really open to regulate himself. What do you think? I mean, in that case, in cases where people would be a bit reluctant to regulate.
There is an analogy from the financial industry in here. You know, if you look at financial risk management in banks and financial institutions, for example. There is a concept of, when you talk about capital, appropriate levels of capital that a financial institution owns, there's going to be something called regulatory capital, where the regulator will say, based on your characteristics, you have to have so much of a proportion of your assets in capital. But there's also a concept of economic capital. And this is accepted, as normal in financial risk management, where the institution makes its own decision in terms of, all right, this is what we need to do to satisfy the regulators, and we'll do that. But in order to satisfy our own organizational requirements, the requirements of our members, our account holders, to keep our assets safe, this is what we have to do. And it's very normal for that to be at a different level. So I think when you put it in that context, the regulation is not necessarily the big burden. It's the burden of what the organization says itself is right.
So not seeing it as a restrictive part, but as a positive part to enable you to economically grow as well. Well, okay, that's a kind of positive statement. Actually, we still have a bit less than 20 minutes. Shall we maybe give the floor to the audience if there are some questions? I see some questions here. Maybe the lady in the front was the first one raising hand. Please, here.
Hi, good morning. I'm Cheyenne, and I'm a PhD researcher, and I specialize in explainable AI. So I would like to ask you just 2 short questions. What do you think XAI, explainable AI, can add the most value as more AI applications are used for space missions? And the second question is, as we explore the emerging capabilities of GenAI, what other AI concepts such as AGI, artificial general intelligence, are being considered for investigation and experimentation?
Does anyone want to?
I can jump in on that first one.
Okay.
So through the explainability, so Lockheed Martin has our own principles. As you mentioned, there's a lot of different rules on system engineering using AI across all of our products, including space, and one of them is explainability. And I think one of the aspects, and you're the expert in it, that this is going to be more and more important is as we have systems of AIs, right? So in one AI, the idea that it's a black box and add explainability and maybe auditability is good. But we're going to move into a place very soon where there's a lot of AIs talking together and working in a very complex system of AIs. And in that case, I think it's very key to be able to either have a state machine, or however you want to look at it, of the explainability of each module. You can think about living systems this way too, kind of in organs and whatnot. So I think for us, explainability needs to be at that model level, and then we bring it up a level to the system, but it's got to be at the lower level.
I think that first, that will be valuable to extract information from a huge amount of data that we will generate. And it's the only way to have really support, to have the right interpretation of this, first. And second, just following what Chris said, as soon as we will move to more sophisticated, which means to have agents that will work, we need to have a kind of model to understand what each agent is doing in its environment. And I think that looking to what Adam said, I think this is really a challenge, for instance, to have a sustainability planet exploration like on the moon. And I take just a few seconds to give a comment to what Adam said, because I fully agree that self-regulation will be fundamental. I mean, the technology is going so fast that, of course, we need the regulations. But the regulation will never prevent what technology can do. And I think, and this is extremely important from an engineering standpoint, I think that we need to have more and more piece of the organization look into the ethics and maybe also philosophy working with the engineers, because self-regulation will be fundamental.
Yeah, if I may add something, I mean, space missions are very complex, are system of systems. So it's something very complex, and all those systems, they have different requirements, different needs, different elements. So we see very important, for instance, one case, how you handle the operation of a space mission. This is something very, very, very tricky. You know? We have one of the projects that we are running currently is really related to make operation efficient. And you have there different problems like enhanced interaction. No? How you can improve your interaction with those diverse systems that have different requirements, different way, and different needs. Efficient data management within all those systems. You really need to see, depending on the different elements, how and those different elements sometimes, in case of AI, are different databases. So you have really to see how you are managing all those elements. Rapid response time, Massimo was mentioning. There are situations in space where, I mean, you need to be quick, otherwise you are dead. Production ready system. So you have to really try to ensure that those systems are ready for deployment when they are due. So there are many elements. Also, a rapid and advanced capability of search the data that you effectively need. So and within all those topics, you will have maybe different solution and different way of handling. We have in space mission, being the complexity we are handling, we normally shall have a big amount of data. Sometimes in space we miss data, which is a problem. But if we want really, we are advancing in exploration and in all those things, the amount of data will be higher and higher, no? And then for helping the astronaut, for taking right decision, for deciding to go here or the other way without killing yourself, I mean, you will have to handle different problematic at the same time. No? So security, rapid responsiveness, many things are needed.
Thank you. A word from the academic side?
I just want to maybe address, take a shot at the second question, where you answer, like asking mainly what should be the next, like things to look for, like to developments, the interesting things. You mentioned AGI. I'm not really going to treat the AGI question, but I think one of the things that we haven't talked about yet is that all of these models come at a high computational cost. And if we're here talking about sustainable, like the sustainability in space, we tend to forget the amount of resources used to generate these models and to use them. So I think one of the most important things for research to focus on is, I mean, from a pure technical point of view, because I'm interested in advancing the AI world, And I think one of the most important things is to work on frugal models, like highly computationally efficient models, improve the processes. I don't think explainable AI, adding a layer to explainability is actually going to reduce the computational complexity. It will increase it. And I think maybe which is very important, right? So explainable AI is one of the most important things that we should be working on. But I think also we should be working on developing more efficient algorithms and computational systems.
Thank you for this Thank you for this very different insights we had, but I have the feeling that big data is the word now, and the management of these data is going to be quite a challenge in the future in our AI, and the infrastructure we will have behind this managing big data will be also something we have to consider for sustainability. Another question, maybe? Yes, please, here. And then we'll have to go there as well, on the other side as well.
Hi, thank you. I wanted to follow up on my friend's question here. I'm also a PhD candidate studying generative AI and explainable AI for space missions at Purdue in the US. And I wanted to ask you about a key limitation or a challenge that we have nowadays, which is something that you guys mentioned. The elephant in the room is data availability. So when it comes to space missions, especially space missions to cislunar space, for example, we don't really have enough data available, and even the data that we do have is usually restricted to companies. So when it comes to that issue, what are your insights on how to circumvent this issue and be able to generate data, be able to use generative models despite having this key challenge? Thank you.
Who wants to go first?
It's very tricky because, as you mentioned, data are the basis of companies, so and they are protected. I mean, and it's true every time for instance, sometimes we work, a company like mine, we work at subsystem level, and sometimes we miss system level data and we cannot get them because they are restricted, and it's very, and even sometimes they are restricted within ISA themselves, so data are a problem. Now, the question here is, we are talking a lot about space economy, ecosystem, so I think if we really want those things to happen, apart from the self-regulation, we shall also put in place, I don't know why, I don't have an answer, mechanism for sharing data, because we are all suffering of missing data. And there will not, I mean, maybe one day there will be 300 missions every day, I don't know. If there will be only one mission every 5 years, the data are from that mission, so.
Yeah.
In the States, yeah.
Yeah, well, and of course, I'm sure you're well aware, but a lot of groups have had to move to synthetic data, right? So you only have so much data. You're not going to get more except for at great cost. And one benefit of synthetic data, like you think of self-driving cars, is you can also speed it up. So you don't have to do it at real time, right? You can generate, faster than real time data. Now you can't always trust it, but if it's all you have, you can simulate on it, work on it, and then as you do get little bits of real data, you can check that against your models and then update your simulated data. So I think we have to be thinking about that. That's how self-driving cars, you millions of miles, but billions of simulated miles. There's rarely a giraffe crosses the street, but you want to try that out, right? So you put a giraffe across the street and make sure the car stops. And the same thing with space-related data as well, I think.
I think that Adam gave an example of how from a single shot taken far from the Earth, you can establish, let's say, positioning with high precision. So I think that if we believe that GenAI will contribute to all of that, synthetic data will be fundamental, and we will learn mission after mission how to refine a model between real data and synthetic data.
I'll just say, this seems to be, to me, one of these areas when one is reviewing a system that you get to the question of, is it scientifically and technically robust? Do you have everything lined up so that simulated data makes sense, or is it too far away that you might be getting into trouble?
Just want to comment on this because I think it's very interesting what Christopher mentioned here. Actually, I'm supervising a PhD student who's working on developing scenario generation models for autonomous vehicles, and that the aim is to train the autonomous vehicle to learn how to drive, self-drive. And we focus on the reliability and risk aspect of it. So indeed, we want to generate the scenario as the giraffe, which is very hard because it happens, like if you really want to take the data set, like actually don't have data about that, right? You don't have data about every possible scenario that can happen, and it doesn't exist simply. But you want to generate it because you want to train your models on like all the possible scenarios that might happen, right? And to that point, what we do, and also like maybe it's kind of something also that Mariella touched upon, is that what we do is that we're using generative AI models to create ontologies, like knowledge management systems, through which we can actually generate scenarios that maybe haven't occurred before, even in the data set. And I think this direction, like we're trying to use it now for the autonomous vehicle, but I think this direction should be really explored in space research as well.
Thank you very much. It was quite an interesting question. Indeed, training the tool and getting better scenarios. This was also something we discovered as well while doing our little trial on Artemis. So maybe we could take 2 questions in a row then here in this area, and then you can choose what you want to answer, because we are a bit, we still have 7 minutes left, and I don't want people to be frustrated if they cannot ask their question. So there was someone close to you as well. Maybe you could give him the mic afterwards.
Andrea Sportillo from Onera, PhD student as well. My question is related to human error in annotations, because most of the applications still today use training as an example based on human annotations. So from a general point of view, does this error propagate through the models that we use today? And is it a risk that need to be managed? And how we can characterize these errors propagation eventually?
Question here. There was another person here who wanted a question. I saw 2 hands rising. Or so nobody on this side. Okay, so maybe it's fine. So you can answer if you wish the question.
So maybe I can try to answer to what I understood the question. So it's the errors in the models and how they propagate throughout the training and like how they impact the risks at the end, right?
Errors in the annotations. So
okay, good.
Human create the labels, and then there are some errors in that.
Gotcha. Well, obviously, if you have errors, like you know, like if you have bad quality data, you get bad quality output, right? So that's an obvious statement. But I want to maybe come back to something Christopher said earlier on, and what I mentioned in the beginning when I said in our research when we discovered that using the LLM models, the foundation models, and just use them as they are to just generate reliability metrics for some components failures for robotics and stuff like that, we realized that they actually produce unreliable results. And then Christopher mentioned that what they do is they fine-tune these models, right? So they fine-tune these models using their own expert systems and data that they have, right? So this is what we call like creating your expert agent within these models. Like you take the foundation model, the LLM model, and then you start fine-tuning it with the expertise that you are looking for. For example, I know for a fact that there are now companies that are doing this for legal. So LLM models that are just experts in legal and they can produce legal documents and they train them on legal documents and so on. I'm yet to know if it happens in risk and reliability world, but maybe probably it exists somewhere. And what you do here is you keep fine-tuning your models, right? So you keep improving by giving it, like getting feedback. I mean, this is the process, right? Getting the models and seeing that they're not really giving you the results that you expected, and then you keep fine-tuning them towards your specific goals. So yeah, error is inevitable if you have errors that you're gonna get like a not so good result out from the other side, but you constantly try to work on that. Yeah.
Chris, you had some thoughts on that as well?
I think that covered it, yeah.
Okay, fantastic. We still have 4 minutes left, and I had a question to you all, basically. The other day, I was listening at the radio, and they were saying that, I think it was researchers in the US in Harvard school, business school, which a researcher was trying with his team of researchers to set a clock to say on which date AI in general, not generative AI, but AI in general, will take over human intelligence. So, you probably have heard about the apocalyptic clock, the last day of this universe, but this is another type of clock, and kind of pessimistic one, it rings a bell. I suppose some of you have seen the film Terminator. So it made me a bit wondering, are you positive or are you fearing AI in the next decades? And maybe one word of each one of you. And if you were the king or queen of a day, what would you like AI to be doing in the next decades? Maybe we start with you, Professor.
So thank you. So the first question is on what is the day that this will take over? Well, I don't look at it like that. I think today's capacity in some of the models have far surpassed what any human can do anyway. Not in all the tasks, but in specific tasks. Like we have models today that can do things that I don't know any single human who can do them. So I think it's going to be kind of complementary. Our job is probably to find how we can work with the tools that we have created, as we all have always done, right? And not to fear that they're the replacement. Like this is not my position about it's my philosophy that it's going to be replacing. It's going to be complementary. So we're going to be using these tools to advance ourselves as we have always done. And
the second question
on
because you're a bit tight on time.
Yeah, so I'm gonna go very fast. I think what I would have loved, or what I hope will happen, is that these capacities will allow us to have more reliability, better risk management. We prevent disasters and challenges that have happened before because we were not able to communicate well between the teams and so on, and now, or identify the right reason and so on. And I hope that this will see great reduction in disasters, that have human impact.
Helping disasters management. Thank you so much, Massimo.
Of course, it's very hard to respond. I mean, I really think that one of the critical points is that the debate on the scientific community is the discontinuity moment when an AI, GenAI, may work and will have the computational power to work on itself. And this is, of course, something that will mark. But I think that we will discover just on the way. And I link what Adam said. I don't think that there is artificial intelligence and other intelligence. I mean, it's a complementarity, and we need to work. We don't have just a single intelligence. We need to work with the human intelligence together with the AI as an opportunity to understand really well.
To progress humanity, maybe.
Yes, we
at
cannot
the end,
ask
at the
for
service
now.
of humanity.
Now. And again,
Okay.
I think the ethics will be really extremely important for the self-regulation that you mentioned. Without that, no way. We cannot respond.
Thank you, Massimo. Christopher, we're a bit running out of time, so
No, but very quickly, I would
thoughts.
say that I think we should be positive on how AI is moving. If you think about electricity or computers, none of these technologies actually reduced the number of jobs, right? It actually increased the number of jobs for humans and the creativity that we're able to apply to the world. And on the second, I think that how that applies is really medicine. So human medicine, right now we have, our healthcare, I suspect will be considered rudimentary compared to in just a few decades. Because what AI does well is use enormous amounts of data and customize it to people, right? And right now we have a medical system that isn't customized to each person, and that could be the revolution that really
It is already revolutionizing in the medical area. Indeed, in epidemics, for example, it's helping so much. Mariella, what are your thoughts?
I'm going to be very politically incorrect because I fear more stupidity than artificial intelligence. I'm sorry. So, what I think shall we do? There is, together with those things, there is a clear change of also within the education, because we cannot have those techniques which shall be for the benefit of human being, in my opinion. Together we're losing the capability of critical analysis. So I think there shall be also a mechanism that, in my opinion, is not happening in having the, I mean, the brain is one of the, our body, human being, we are unique, so I think we need to preserve this and using all we are doing in our benefit, not in controversy.
Yeah, thank you. The uniqueness of human being. Adam, what are your thoughts?
I just took a picture of the audience. I went to a Ringo Starr concert, and he did that at the end to thank the audience, and we really thank you for coming. And my thought is, I think that it's going to be like a J-curve, where there's going to, any new technology, there's going to be some noise at the beginning, expectations not met, a little bit of confusion, but then at some point, it will take off, and it will ultimately come ubiquitous. And I think with regard to self-regulation, I would say that the quality of the eventual regulation will be very favorably influenced by the high quality of self-regulation, if that's achieved. I think that's an important objective. And if, in terms of what I can see for, future uses, this might be a little modest. I think, Anna Maria thought if you were king or queen for a day, this is more of, baronet or an earl. I would just be happy if we had systems. It used to be legal opinions were very formal, and now we just do all these emails. It's very hard to record them. If we had automated AI that could reliably preserve those records, so that knowledge could be used effectively going forward, I think that would be very helpful in the legal and other professions.
So many messages of hope. Thank you so much to my distinguished panelists. A round of applause for them. Thank you.